Okay, Mr. Burrell here. We're in Unit 8 here. We're talking about graphing. We're talking about different types of graphs. Specifically today we're going to get into parent functions. I'll explain what that means as we go throughout this video. There are lots of different functions out there. There's lots of different equations, lots of different varieties, lots of different types. So what we're going to do today is we're going to kind of categorize those different types of functions into 6 main groups that we can kind of identify. So by the end of this lesson, I hope that you're able to sketch each of the 6 main parent functions, and we'll talk about each of those main parent functions. But I hope that you're able to sketch each of those on a graph. And second, I hope that you're going to be able to identify a parent function given an equation. So that's kind of the things that I expect you to be able to do after this lesson. It'll be handy if you have access to one to use a calculator to kind of follow along with some of the graphing that I do here. But basically, I'm going to give you a bunch of expressions. I have a bunch of equations right here. And you're going to graph them and then see what they have in common. I've kind of already grouped them together for you. But what I want you to do is hopefully maybe pause this video, go into Desmos or a graphing calculator, graph these different equations, these different graphs, and see what you notice. So notice I have a bunch of different types of expressions. And in your calculator, if you do y equals each of these expressions, you'll be able to find a graph for each of these different types of expressions. So after you have a chance to graph these, what I want you to notice is some of the things that are in common between all of these different types of graphs. So right here I'm going to sketch what this graph would look like. All of these types of equations in this type of form is going to look like this, or like this. Some sort of U or upside down U shape is what those are going to look like. Expressions like this in this form are going to look something like this, kind of like a swoopy J situation. Expressions like this, x plus 5 to the third, 3x to the third, those are going to look like this, kind of in that shape, like a squiggly noodle type of deal. Equations that look like this are going to look like a straight line type of a deal. Equations that look like this with the square root there are going to look something like this, kind of like a half curve. And then these ones down here are called absolute value bars. They look something like this, like a V. So these are a bunch of different types of equations, but I can categorize them kind of into these 6 groups. Over here, some of the characteristics that I want us to think about these different types of expressions. First of all these graphs in this first group are all kind of U-shaped, you'll notice, and they all have an x squared. They all have an x squared here. Here, these, I like to describe this as the swoopy J. All those have an x as an exponent. You'll notice that each of those in the exponent has an x. All of them have that in common. So an x is the exponent in all of these equations. Here I call this the squiggly noodle. Squiggly noodle. And what they all have in common as well is they all have an x cubed. There's a power of 3 here in all of these expressions. These characteristics, these are all lines. They're all straight. And notice that all of these x's, they don't have any exponents. So there's just x's. Here, these all have like this kind of half curve situation, and they all have a root symbol, specifically in these ones, a square root. So that's something they all have in common. And down here, I have a bunch of v's. These are v functions, and they all have these absolute value bars. So this is kind of the way that we're going to organize these different types of functions. Okay, so let me move on. We're going to talk about what to call these different types of functions. Oh, whoops. Let me move this out of the way here a little bit. Okay, so let me get out of here. If I were to write those equations as basic as possible, they would look something like this. Y equals x cubed, y equals the absolute value of x, y equals x squared, y equals the square root of x, y equals x, and y equals something to the x power. So I want you to follow on with me as I graph each of these expressions, what they're going to look like. Y equals x cubed is going to look like this squiggly noodle here. Y equals the absolute value of x is going to be this v. Y equals x squared is going to be this u. This is going to be the square root of x. This is going to be y equals x, kind of right here, going through the origin. And something like this is going to be an x, where x is the exponent, kind of this swoopy j. These are the 6 main different types of graphs or parent functions that we're going to see. And those are called linear, quadratic, cubic, root, absolute value, and exponential. That's the mathematical terminology we're going to use to describe each of those 6 functions. So if you're in my class and you have a pack of guided notes, there's a page in your guided notes that looks like this, where you're able to write the group names, the equations, and the graphs. So each of these group names are going to be linear, quadratic, cubic. I believe the next one is going to be the root function. Then we're going to have the absolute value function. And then we're going to have the exponential function. So I believe that's the order I have them listed. What I want you to do is I'm going to pop up a Desmos graph here. I want you to write down what the corresponding equation is for those parent functions and what the corresponding graph is. So I'm going to go out of here for a second. Okay, yes, I did give them in the right order. So notice here, I have y equals x. This is my linear function. It comes right up through the origin, right diagonally through the origin. So in there, next to your linear functions, you can write y equals x, and this graph right here, it has to cross through 0, 0. That's a linear function. This one right here, y equals x squared, is a quadratic function. So it's this u. We also call this a parabola. That's a word that I'm going to use now and again. So this parabola, or this quadratic function, comes down, intersects at the origin, 0, 0, comes back up, and it's denoted with an x squared. That's a quadratic function. This is a cubic function because it's x cubed. That denotes a cubic function. So this cubic function, it kind of has this squiggly noodle situation. It comes up through the origin and then up again. That's a cubic function. So next to your cubic function, you write y equals x cubed, and this graph right here going through the origin. Next is our root function. This is specifically a square root. That's not the only one that we can see. It's the one we see most often. But it's denoted with the equation y equals the square root of x, and it's almost like a half parabola tilted on its side. So this little half parabola, this half curve coming off, starting at 0, 0, that's a square root function. Next, we have y equals the absolute value of x. That's going to be this v. If you know anything about absolute values, you know absolute value makes whatever is inside of those bars positive, which is why just with this normal y equals absolute value of x function, everything, all of the y values are positive. Everything from here up. It's almost like I shot a laser down at a mirror and then had it reflected back off. That's an absolute value function. And then the last one we're going to discuss is an exponential function, kind of like this swoopy j. So there's not just one parent function for an exponential function because it depends on what the base is, this number a. So right now you notice I have a equals 2. So this function would be y equals 2 to the x. And notice, let me zoom in here, this function crosses not at the origin, but it crosses the y-axis at 1 here. This point is 0, 1. And then as I keep going this direction, you notice it just kind of hugs this x-axis. So it looks like this. So when you're drawing this specific graph, make sure that you draw this curve coming through this point, 0, 1. And then notice as I change the base here, notice what happens to my exponential function. It still crosses through that same point, but as this number gets bigger, the graph kind of gets steeper. Not super critical information to know right now, but the big part that I want you to recognize is that this x right here is an exponent, which makes this an exponential function. So those are the 6 types of functions that we're going to be focusing on, that we're going to be discussing throughout this whole rest of the unit. Linear, quadratic, cubic, root or square root right here, absolute value, and exponential. Those are the 6 functions that we're going to be discussing. So if I come back into our PowerPoint, if I were to give you some functions like this, these functions that we start off with, those would be quadratic functions because they are squared up here. They have x squareds. These would be exponential functions. These would be cubic functions. These would be linear functions. These would be root functions, or specifically here, square root functions. And these would be absolute value functions. So we're going to be talking about in this unit how we identify these different types of graphs a little bit more. But right off the bat, I would want you to be able to identify somewhat what each of these graphs would look like based on these functions and some of the characteristics you've already identified. So these are the things that I want you to hopefully be able to do with this video. I want you to be able to sketch each of those 6 main parent functions: linear, quadratic, cubic, absolute value, root, and exponential functions. I hope you're able to graph a rough sketch of those, and I hope that you're able to identify a parent function given some equation. So that's the lesson I have for you on parent functions. I hope that was helpful, and I hope that you enjoyed that as much as I did.